Good afternoon. Welcome again to Smart Learning at Andalusia. I'm teacher Percy Draniga, your teacher of maths. Last episode, we looked at how to factorize quadratic expressions and also how to solve quadratic equations by factorizing. And I told you that we are going to introduce completing squares in this episode. So before we introduce completing squares, let us have a review of the quadratic identities which give us perfect square. We said that x plus a squared can be expanded to x squared plus 2ax plus a squared. Now, if I compare this equation with the general quadratic equation, I'm going to have ax squared plus bx plus c. Now, for a perfect square, you can see that our a is 1. B in this case will be 2a because b is the sum of the products. And our c is going to be equals to a squared. The same way, if we had x minus a squared, when I expand, will be x squared plus 2ax plus, this should be minus, then we have a squared. Again, my a is 1. Now my b is minus 2a, and my c is a squared. So this is when we have a perfect square. For example, if I have x squared plus 4x plus 4. Now, if I compare this one here, my b is 4, and my c is also 4. Now, if I compare this one, my b is twice the factor. My b is twice the factor, and my c is the square of the factor. C is the product, b is the sum. So, in order to get the factor here, I divide my b by 2. So, 4 divided by 2 is going to be equals to 2. And then to get my c, it will be my b over 2 squared, which is 2 squared, which is 4. So in this case, I can write this one as a perfect square, which will be x plus 2 squared. So in this case, I have an expression of a perfect square. But suppose I don't have a quadratic expression which is a perfect square. For example, if I have x squared plus 6x plus 4, how can I use this identity of perfect square to write this expression in the form of x plus p squared plus q? Now, I want us to try and write this one. How do we get our p? Let's borrow the fact that our b is twice the factor. So here, my a is 1, b is 6, and c is 4. I want to try and divide 6 by 2 so that I get my factor. So that my p is going to be equals to b over 2, which is 6 over 2, and I get 3. Now, if I write x plus 3 squared and I expand it, I'm going to have x squared plus 6x plus 9. Now, and then if I bring my 4 here, I'll have x squared plus 6x plus 13. But this is not the same equation as the original one. Now, what should I do to 13 in order to get 4? I have to subtract. So I'm going to have x squared plus 6x minus 9 plus 13 will be exactly the same as our equation. So let's try to look at what this negative 9 represents. If you see carefully, our factor is 3. And we got 3 by dividing 6 by 2. So if I can write x plus 3 squared minus 9 plus 4, this is exactly the same as my original equation. So what is my negative 9? It will be x plus 3 squared minus 3 squared plus 4. But our 3 squared is b over 2, which is your p. So we are going to have x plus 3 squared minus 6 over 2 squared plus 4. Now, you can see here that I have a way of trying to make sure that I can complete squares at the same time retain my original equation, which means I'm going to have my x plus p squared plus c, which in my case was b. Not b, but p, sorry. Plus p. So let's try to find an equation which we are going to use. So when I have ax squared plus bx plus c, and I want to write in the form of x plus p squared plus q, how can I get my p? P is my factor, and in this case my a is equals to 1. So my p is going to be equals to b over 2. And then my q is going to be equals to c plus b over 2 squared. But this one is going to be plus or negative. But in most cases, we have to subtract. So I'll remove the positive. So we have to subtract our b over 2 squared. So when you are given an equation, what you need to do is that to write a quadratic expression in form of a perfect square, you are ax squared plus bx plus c in the form of x plus p squared plus q. Your p is the factor, which is b over 2, and your q is the sum, which is c minus b over 2 squared. And this is possible only when our a is equals to 1. So we are going to have some examples. Let's say, for example, I have x squared plus 6x plus 3. Now, we are first going to use the formula to make it easy so that you get used to it. How do I get my factor? I want to write in the form of x plus p squared plus q. I said our p is equals to b over 2, which in this case is 6 over 2, which is 3. And my q is equals to c minus b over 2 squared, which is 3 minus, now b over 2 is 3, so squared will be 9. So it means that 3 minus 9 will be negative 6. So I'm going to write, so my x squared plus 6x plus 3 is going to be equals to x plus 3 squared minus 6. Now, instead of using the formula, let me take you step by step. So, our b is that. I'm going to divide it. So, I have x plus 3 squared. And then make sure that you subtract the square of your p, which is the b over 2. So, minus 3 squared plus 3, which gives you x plus 3 squared minus 9 plus 3, which will be x plus 3 squared minus 6. So, you can use this formula or you can move step by step. But remember, to get the factor, you have to divide b by 2. And then, to get your q, you have to add, or you have to subtract b over 2 squared from your c. Now, let's get another example. Here now I have x squared minus 8x. X squared minus 8x plus 21. So, if I use the formula, my p is going to be close to b over 2, which is going to be close to negative 8 over 2, which is negative 4. And my q equals to c minus b over 2 squared, which will be 21 minus, now 4 squared is 16, so subtract 16, this will give me 5. So my expression becomes x squared minus 8x plus 21 will be x minus 4 squared plus 5. That is what you have to do. So, when a is 1, it is quite simple. Divide b by 2 to get the factor. Write in this form. And then, to get your q, add the negative of the square of b over 2 to your c. And you get your answer, which is quite simple. Now, suppose your a is not 1. What happens if your a is not 1? So, if a is not 1, so we have ax squared plus bx plus c, but a is not 1. So it means that before we complete as a perfect square, we must divide everything by a. I give you an example. Let's say I have 2x squared minus 8x plus 10. I want to write this one in the form of x plus p squared plus q. Now, the first thing I have to do here is divide everything by 2. So what I'm going to have is, if I divide everything by 2, I'm going to get x squared minus 4x plus 5. Now, this means now this is going to be my new b. Let's call it b1. And this will be my c1. But how do I get my b1? My b1 is equals to the original b divided by a. And my c1 is the original c, which is c divided by a. Because our original c is 10. Now our a is 2, so 10 divided by 2 is 5. And our original b is negative 8. Negative 8 divided by 2 is what? Is negative 4. So now, I have to now use this one. I know to get my p, I have to divide b by 2. But my b here is b1, which is actually my original b divided by a. So which means my p is now going to be equals to the original b divided by 2a. So that is how you find your factor if A is not 1. The second thing we are going to do now is to get our C. Remember, our C is, the C1 is C over A. So to get our Q, we say it is C minus B over 2 squared. But this, in this case, is my B1. And my B1 was got by dividing the original B by A. So my Q is going to be equal to C minus the original B over 2A squared. So we have now changed because our A is not 1. So let us use this in order to solve this. First of all, we are going to do it the easy way, which means I have x squared minus 4x plus 5. I get my factor, which is x minus 2 squared, and then minus 4 plus 5. This becomes x minus 2 squared plus 1. Now, let's try to see if we can follow and get the exact thing by using the formula. So, let's come here. What is my B? My B is negative 8. So negative 8 divided by 2 squared is what we are going to use here. So to get P is equals to negative 8 divided by 2, and our A is also 2, which is negative 8 divided by 4, which is negative 2. Exactly what we have got here. So when we use the formula and you are used to the formula, it's quite easy for you to get. Then let's get our Q. We say Q is C minus B over 2A squared. Our C is 10 minus, remember our B over 2A we got was negative 2. So B is, let's use the number so that we get, so what is our B over 2? That will be negative 8 over 4 squared. So negative 4 over that squared is going to be close to 10 minus 4. But remember, this one is going to give us something which we have to divide by 2. So we should get exactly the same thing, which is x minus 2 squared plus 1. So it's easy to use the formula, but you can also go step by step. Let's get another example. 2x squared plus 6x plus 1. Now, I want to write in the form of x plus p squared plus q. Now, of course, we have to divide everything by 2, which becomes x squared plus 3x plus 1 over 2. Then we have to divide 3 to get by 2 to get the factor, which becomes x plus 3 over 2 squared minus the square of this, which is 9 over 4 plus a half. 4 is our LCM, so we are going to have minus 9 plus 2 over 4, which becomes minus 7 over 4. So our expression becomes x plus 3 over 2 squared minus 7 over 4. It's quite simple. So what you need to do is divide everything by a, then you get your new b, which you are going to divide by 2 to get the factor, then subtract the square of the factor and add it to c, and you'll have completed your square. Now, there are cases when you have to do it in a different way. Let's say I have ax squared plus bx plus c. But this time I want to write in the form of a in bracket x plus p squared plus q, which means that I have factored out my a. So what we do? This means that if I give you an equation like 3x squared minus 27x plus 9. First of all, I must factor out my 3. So it becomes 3 in brackets x squared minus 9x plus 3. Now, I can try and complete squares the same way I did there. So my b is negative 9. So what I do here is I write 3. Let me put a big bracket. So I'm going to have x minus, if I divide this one by 2, I'll get 9 over 2 squared. Then I must subtract the square of this one, which is 81 over 4 plus 3. Now, you can see q is out of the bracket. So first of all, let's try to evaluate this, and then we multiply by 3. So what we are going to have here is 3 in brackets x minus 9 over 2 squared. Now, my LCM here is 4, so this would become negative 81 plus 12 over 4. Now, negative 81 plus 12 becomes negative 69. So we are going to have 3 in brackets x minus 9 over 2 squared minus 69 over 4. Now, since our q is outside the bracket, we are going to multiply this constant factor by 3. So I'm going to have 3 in brackets x minus 9 over 2 squared. Now, 69 multiplied by 3, that is, will be minus 207 over 4. And now let's factorize. So you can either write in the form of x plus p squared plus q, or a in bracket x plus p squared plus q. Now let's try to see how the formula changes when we are using this factor. Remember, here we are factorizing, which means that everything will be reduced or divided by 3 in order to get the factor. So let's try to have another example. I have 3x squared minus 12x plus 2. I want to write it in the form of a in brackets x plus p squared plus q. So here our factor is 3, so let's put 3 outside. Put the big bracket. We are going to have x squared minus 4x plus 2 over 3. Now, our new b is now negative 4, so we can complete squares. So we're going to have 3 in the big bracket, x minus 2 squared minus 4 plus 2 over 3. Now, my LCM here is 3, so I'm going to have x minus 2 squared minus, this becomes minus 12 plus 2 over 3, and that becomes negative 10. So our answer becomes 3 in brackets x minus 2 squared minus 10 over 3. But remember, our q is out of the bracket, so we have to multiply that one by 3, and we're going to have 3 in bracket x minus 2 squared minus 10. and you'll have done it. It's quite easy to use step by step, but you can also use the formula I've given you in order to get your P, your Q, and just plug in the equation. Now, let me try to give you another example where maybe you'll be forced to rearrange the equation. Let's say you are given 4x equals to 3 minus x squared. Now you can do it in two ways. One, you can take the 4x to the other side so that you have your 3 minus x squared minus 4x equals to 0. Now in this case we're lucky because our a is -1. So what we do is we write 3 minus, in brackets, x squared plus 4x. Now we can complete squares here now. We have 3 minus x plus 2 squared minus 4. So our 3 minus 4 minus x plus 2 squared, of course, we remember this one is subtracting a 4 here. Let me remove that one. So that actually when we subtract, 3 is positive, 4 is negative. So we are going to have minus, here we are going to have minus 1 minus x plus 2 squared. And you'll have completed your square. So sometimes you'll find that your equation has to be rearranged in order for you to complete your squares. Now, the final part of our equation should be the formula so that you'll be able to remember. I'm going to write them here. So when I have ax squared plus bx plus c, I want to write in the form of x plus p squared plus q, and our a equals to 1. How do I get my p? P is equals to b over 2. P equals to b over 2. And how do I get my q? Q equals to c minus b over 2 squared. That is how quickly you can get your p and q if a is 1. Now, if a is not 1, and still you want to write in the form of ax squared plus bx plus c in the form of p in the form of x plus p squared plus q. Now, remember, first of all, we have to divide everything by a. So, my new b1 is going to be equals to b over a. So that if I have to get now my p is going to be equals to b over 2a. Now, remember here, our a is not 1. And our q is going to be equals to c must be divided by a minus b over 2a squared. If you want the expanded form, you can say is equals to c over a minus b squared over 4a squared. You can use that one. So that is if our a is not 1, but we still have to write in the form of x plus p squared plus q. Now, suppose you have your ax squared plus bx plus c, but this time I want to write in the form of a in bracket x plus p squared plus q. You see that we have to factor out our a. And that means everything must be divided by a. So I write a, then I must have a big bracket. So I'm going to have x squared plus b over a x plus c over a. Now, when I complete squares, I'm going to have x plus b over 2a squared minus b squared over 4a squared plus c over a. Now remember, our p does not, q does not have to be in the bracket. So we are going to have this one as our a in bracket x plus b over 2a squared minus. Now if I multiply this one by a, I'll get b squared over 4a, because this a will cross with one of the a's plus c. So you can see how we are going to get our p and q. So our p is still going to be equals to b over 2a, but our c is going to, q is going to be equals to c minus b squared over 4a. So those are the main important formulae which you can use to simplify your getting your quadratic expression in the form of a perfect square or a completing squares. Now, I'm going to have two more examples so that we can be able to have you well versed with completing squares. Quickly, let's do this. 2x squared minus 3x minus 5. Now, we are going to do it in both ways. We are going to write this in the form of x plus p squared plus q, and later on we are going to factor it out. So, since our a is not 1, the first thing we have to do is divide everything by 2. So we'll get x squared minus 3 over 2x minus 5 over 2. Now I get my factor by dividing b by 2, so I'll get x minus 3 over 4 squared. Then I have to subtract the square of this one, which is minus 9 over 16 minus 5 over 2. So my LCM here is 16. So I'll have minus 9. This goes 8 minus 40 over 16. So I'll get x minus 3 over 4 squared minus 49 over 16. And you'll have done it. That is if you want to write in this form. Now, the second part I want to write in the form of a in brackets x plus p squared plus q. So quickly, what we have to do here is factor out. So I'll have 2 in brackets x squared minus 3 over 2 x minus 5 over 2. Then I complete squares here. I'll have 2 in brackets. I divide this one by 2. I get x minus 3 over 2. Let me write it clearly. It becomes x minus 3 over 4 squared minus 9 over 16 minus 5 over 2. Then let's simplify that. We get, again, the same thing, minus 49 over 16. And then you multiply by 2 and you get your answer. So, I hope you have understood all the steps of completing squares. 1, your a should be 1. so that you can write in the form of ax squared plus bx plus c should be in the form of x plus p squared plus q. I've given you the formula of how to get p and how to get q. And if a is not 1, you know what to do. Divide everything by a first, and then the new b will be divided by 2 to get p, and q will be got by your c over a minus the new p squared. And you can also write your ax squared plus bx plus c in the form of a in bracket x plus p plus q. In that case, you have to factor out complete squares and make sure you multiply your new c minus b over 2a, squared by a to get your q. And that will complete the way you get your completion of squares. And I hope you have understood all what we have been doing. At least now you should be able to factorize quadratic expressions, solve equations using factorizing. You should be able to complete squares and be able to solve quadratic equations by completing squares. In the next episode, we are going to look at the quadratic formula and quadratic graphs. Thank you very much. I have been your teacher, Percy.